In this video, we begin our discussion on summarizing and visualizing data. Without any further ado, we begin on page 2 of your notes. It is my assumption that you are working with a blank copy of this completed notes. So what I'm going to do is to walk you through the ideology of the completed notes. You're welcome to pause the video to write and complete your notes as you progress. So we begin with one basic fact. At this level of statistics, most of the data you will encounter might come in the form of a flat file. What is a flat file? An example would be a data set in Excel. Most of the columns of that Excel file would contain data on each of the variables. Oftentimes, the first row would be the name of the variable on which data has been collected. In module 1 or in chapter 1, we did learn that whenever we collect data on variables, they can either be quantitative or numerical variables or categorical or qualitative variables, rather. So again, just to emphasize, a variable could either be quantitative or numerical on one hand, or categorical or qualitative on the other hand. So we begin with a spotlight on a categorical variable. Let's take one categorical variable and let's see how we can make sense of it. The first step is, once you have a single column of data on a categorical variable, the first step will be to summarize that the different data values that you have for that categorical variable. So we take an example. The Super Bowl, the championship game of the National Football League of the United States, is an important annual social event for Americans with tens of millions of viewers. The ads that air during the game are expensive. For example, a 30-second ad during the 2013 Super Bowl cost $5 to $5.5 million. Polls often ask whether respondents are more interested in the game or the commercials. So here we have 40 responses from one such poll. So this is a data set on a single categorical variable. What is the first step? We summarize a categorical variable first by counting the number of cases in each category. Here, we first create a table like this, like the one on my screen. We look at the different response types. What are the different response types here? Commercials, game, won't watch, NA, or even don't watch the Super Bowl. Then we count how many responded with commercials, 8. How many responded with watching the Super Bowl for the game, 18. Won't watch, 12. Don't know, 2. This would be the first step, registering the frequency of each of the different response types. Once that is done, then we progress to the relative frequency. How do you get the relative frequency? Simply take the frequency for each category type or each response type, 8 for commercials in this case, 8 divided by 40, that will give 0.20 or 20%. In other words, 8 respondents who responded with watching the Super Bowl for the commercials represent 20% of the total number of respondents. Then, from this table, we need to communicate our insights. What insights can we see? We can talk, for instance, about the most prevailing or most recurring response type we have. So we see that the greater part of respondents said that they watched the game or watched the Super Bowl for the game, closely followed by those who won't watch the Super Bowl. And this is supported by this summary that we have here. So in a nutshell, back to the beginning, we can summarize a categorical variable first by counting the number of cases, otherwise called the frequency, in each category or response type, and then we can follow that up with expressing the resulting distribution as percentages or decimals. And that is what we have under the relative frequency here. With that done, we proceed to the next page. You see, when we collect data, we begin with summarizing the data, explaining what we see from our summary, and sometimes, and most often, because humans can relate more to pictures, we also try to create a picture of the insights we see. So that brings us to, how should you graph one categorical variable? Precise answer: you use either a bar chart or a pie chart. Whether you're using a bar chart or a pie chart, both of them are based on the area principle. What is the area principle? The area principle says that the area occupied by a part of the graph should correspond to the size of the value it represents. We'll see what that means in a little bit. But before we get into the details of when should we use a bar chart or when should we use a pie chart, let us note that if you are going to use a bar chart, most times we use it to represent counts or frequencies or percentages for values of categories of one variable, of one categorical variable, which may not necessarily be part of a whole quantity. In contrast, pie charts are best suitable when you have a whole collection or a whole entity and you want to show how it breaks down into componential parts, which are represented by the wedges of the pie chart. So we take a quick example. Remember the table, the frequency distribution table that we had earlier? We can represent these insights using a pie chart, which is what we have done here. So on the x-axis, you have the different response types. I have decided to, just by choice, show a different ranking here. We can immediately see that most of the respondents watch the Super Bowl for the game. This is the power of visualizations. Humans readily connect with it, and they can more quickly look at the graph, pick up the insights, and quickly communicate what can be found in that data. Another point is, can we explain whether a pie chart would be appropriate to display this data? Yes, a pie chart would also be appropriate because we had a whole collection of 40 different responses, and we can show immediately that we have a breakdown of the different 40 responses by the different response types. So definitely, a pie chart would also be appropriate because it can show how the whole collection of 40 responses is divided among the different response types.